Alright, this is the video of the solutions for the Activity C review, which is the review for the test on Activity C, which is taking place Friday, April 23rd, 2021. Alright, so what we're going to do is we're going to go through all the problems. They are split up by section, okay, and by topic. So number one, P1, it's the first 5 problems deal with lesson C-1, which was on the circle basics. Okay, so number 1, using the diagram, give an example of each circle part. Okay, the center, there is only one center in this circle, and it is P. Okay, so we'll put a capital P there. That's a point. Alright, radius. There are, I think, 3 radii in here. Radius is in here. And so a radius, remember, is just a segment with one endpoint, the center, and one endpoint on the circle. And in this case, a radius for this example would be segment MP. P is the center, M is on the circle, and you draw a segment between them. Now for diameter, it's just double the radius, but it's also just a chord that goes to the center. And the example we have here on our circle is segment NL. Okay, now for a chord is a little more general than that. Chord is just a segment that has endpoints on the circle, and we'll say for this one will be ML. Not the only chord you could have done, but it's just an example. For secant, we'll say segment JL. It intersects the circle twice, but it's also gone outside of the circle. For our tangent here, the only one that's going to intersect our circle once is segment JN. For central angle is just an angle where with a vertex being the center of the circle. Okay, so let me rewrite my tangent real quick. Central angle, again, vertex being the center of the angle, center of the circle, so P is the vertex. So I'll say, how about angle NPM? That works. Not the only one. An inscribed angle is an angle where the vertex is on the circle, not at the center of the circle, so on the edge of the circle. And in this case, an example of that would be angle JLN. Minor arc. Minor arc is just an arc that's less than half the circle or less than 180 degrees. NM would work for that. Remember, we write that with a little hump over the top. And then a major arc is one that's first off named with 3 points, but it's more than half the circle, or greater than 180 degrees. So I'll just do the major arc that corresponds to this minor arc, which would be, we can name it NKM arc. So N, K, and then all the way to M. It's obviously more than half the circle. A semicircle is exactly half the circle, meaning it's 180 degrees. So its endpoints are endpoints of a diameter. So if you look at here, let's say these are also named with 3 points. Okay, so how about NML, arc NML. These answers are not the only answers you could have had. You might have different. Yours might be a little different than mine. That's fine. If you would like me to check, or if you want to know if yours were right because you still don't know, email me or something like that. All right, 2 through 5 are true or false questions. Number P2, a secant intersects the circle exactly 2 times. That is true. P3, a radius is equal to 2 times the diameter. True or false? That's false. A corrected version is actually the diameter of the radius should be switched in this case. Radius is smaller than the diameter, so it should be diameter equals 2 times the radius. Okay, didn't ask to correct it, but I just thought we would. Number 4, the point where a tangent line intersects the circle is called the point of secancy. True or false? Again, false. This should be the point of tangency, not secancy. P5, the sum of all central angles in a circle is 360 degrees. True or false? That is true. Just the amount of degrees in a circle is 360. And that's what we have for P1 here. Next, we move on to area and circumference of a circle. Okay, I think we have 5 questions on this as well. Find the area and circumference of a circle. So we remember, if you look at our cheat sheet, which is the last page, you'll see that the formula for area is equal to pi r squared, where r is the radius of the circle. And then the circumference is 2 pi r. Or, in terms of our diameter, it's just pi times the diameter. Alright, so let's find our area and circumference. First, let's find our radius. Since we know that here we're given that the diameter is 16.6. We know the radius is half the diameter, so radius is equal to 16.6 over 2. That's just 8.3 meters. Alright, so let's find our area and circumference using our formulas. First we'll do area. That's equal to pi times the radius of 8.3 squared. Okay. So I want your answers in both in terms of pi and a decimal. Okay. So 8.3 squared is equal to 68.89. So in terms of pi, my answer will be 68.89 times pi, right? We haven't multiplied pi yet. All we did was square the 8.3. And that's meters squared. Okay? And then we give a decimal approximation of this, and that comes out to 216.42 meters squared. Alright, for circumference, I'm going to use the diameter formula because we're given the diameter. So my answer in terms of pi is just the diameter times pi, 16.6 pi, which is approximately, that's meters, 52.15 meters. And that's my answer. Okay. Number 7. Find the radius of a circle with a circumference of 106.81 centimeters. So I know that the circumference is 2 pi r. Okay. I'm trying to find the radius. So I set the formula for, I need to have an equation to solve for the radius somehow. So I've got I know I'm given the circumference to be 106.81. So I can just set that formula equal to what it actually is. And then I can do a little algebra to find my radius. Okay. So what I'm going to do here is we're going to divide by 2 pi. And then you put that in your calculator, you get that the radius is approximately 17 centimeters when you round. And that's all it is to that one, guys. Number 8, find the diameter of a circle with an area of 95.03. So we're finding the diameter, and we know the area to be 95.03 square feet. Okay. Area of a circle, of course, is pi r squared. That's going to be equal to this 95.03 because we're given the area. First step, divide both sides by pi. So r squared is equal to 30.25. Okay, we take the square root of both sides of that to get that r is equal to 5.5 feet. Okay, but we want the diameter. And we know the diameter is 2 times the radius, so we're going to take that radius of 5.5 and multiply by 2 to get that the diameter is 11 feet. P9. Find the circumference of a circle with an area of 254.47 square inches. Let's find the radius. Pi r squared is equal to 254.47. Divide both sides by pi. R squared comes out to 81 after you round. Square root on both sides. R is 9 inches. Okay, now we plug this R9 in for R in the circumference formula. So C equals 2 pi times 9, which of course is 18 pi in terms of pi, which approximates to 56.55 inches. That's our answer for circumference. Nice. Number 10, kind of going backwards the other way now. Find the area of a circle with a circumference of 30 pi meters. So 2 pi r equals 30 pi. Divide both sides by 2 pi. R equals. So notice that the pi's will now cancel, and then you're left with just 30 divided by 2, which is 15. And that is meters. But we want the area, so area formula is pi r squared, so pi times 15 squared. 15 squared is 225. So our answer in terms of pi is 225 pi, which approximates to 706.86. And remember, this will be meters squared because area is always measured in squared units. And that's area and circumference. We'll move on now to lesson C2, which is on arcs and central angles. Okay, if you remember correctly, a central angle is an angle that has a vertex at the center of the circle. And we're going to write down what we remember about this. When we talk about the measure of a central angle, so I'm writing up here, measure of central angle is equal to the measure of its intercepted arc. And what I mean by that is just the measure of the arc that is formed by the two endpoints of the angle. So between it, pretty much on the arc that is on the inside of the angle. Like if you have a slice of pizza, okay, the crust would be that arc, okay. For instance, this angle right here, AZB, the arc is AB between those two right there. That's the crust of the pizza. All right, number 11, what's over here? Find each arc measure. Okay, so I kind of like to just go through and mark up my circle before I even look at the blanks, okay? So what I notice first is I see that BZD is a right angle. So BD, arc BD would be 90 degrees. So to find CD right here, we can do 90 minus this 53 and get that it's 37 degrees. Okay. I also notice that EC is the diameter, so arc EDC right here is 180 altogether. So we can find ED, arc ED, by doing 180 minus 37, which gives us that it's 143 degrees. Okay, our last one we have here, if we look at the semicircle on top, it's comprised of 3 arcs, EA, AB, and BC. We can find the measure of arc AB by doing 180 minus 79 minus 53. And that gives us that arc AB is 48 degrees. Okay, now let's see if we can answer the questions or fill in the blanks of what it's asking us to the left. Alright, so measure of CD, we have found that to be 37. AB we found to be 48. ED we found to be 143. EB, so EB is going to go this way right here, 79 plus 48, and it is 127. And then BDE, arc BDE, BDE. So it's this 180 degree plus the 53, which comes to 180 plus 53 would be 233. And then arc DEC, DEC, it's basically the whole circle except for this little 37 degree arc. So we do 360 minus 37, and you get that the arc is equal to 323 degrees. That's P11. P12, solve for x. Okay, so my goal here is to find what the measure of arc RS is and then set this expression equal to whatever it is. Okay, so these are vertical angles in the middle, so their arcs are going to be equal as well. So that's 45. Okay, now VU, UT, and TS are all add up to 180, so you do 180 minus 45 minus 28 to find that this angle right here will be 107 degrees. Okay, so which in all seriousness, I didn't even really need to do that because all I need to know is this angle. So I can, if I knew this was 180, this whole thing right here, okay, and then plus the 45, I could find that this whole thing right here is 135. Right? Oh. No, excuse me. 180 plus 45, you get the whole thing is 225 degrees. Okay, 360 minus that 225 is 135. So that tells me that this arc RS is 135. So here's my equation for x. 6x plus 33 equals 135. We'll subtract the 33 from both sides to get that 6x is equal to 102. And then divide by 6 to get that x is equal to 17. Number 13. Find the measure of arc EF. Okay, so if you notice here, I have my central angles, of course, are vertical angles. So these arcs that are their intercepted arcs have to be congruent. So we just set those expressions equal to each other and solve for x. So we get x is equal to 5. From there, I want to find arc EF, so I can just plug into either one of these. Notice that with the GF and EF together form a 180, so I'll just do 180 minus whatever I get for GF, and that'll give me EF. So 13 times 5 plus 3, that comes to a total of 68 degrees. Okay, so the measure of arc EF is equal to 180 minus the 68 degrees, which is 112 degrees. Alright, number 14. Use the fact that the measure of angle LCR is 90 degrees. Encircle C below to answer the following items. So A, if CQ is an angle bisector of angle LCR, what is the measure of angle LCQ? Okay, Since LCR is at 90 degrees, if it's being bisected, it means it's split directly in half. So half of 90 would be 45, so LCQ would be 45 degrees. Okay. B. Identify two major arcs. Okay, that's just any arc greater than 180. So PRK is one. Arc P, R, K. And then KPQ. That's another one. As long as they're more than 180 degrees. More than half the circle. C. Name two congruent minor arcs. Okay? So minor arc is just less than 180. I have two 90-degree arcs right here. One right there. One right here. Those would be arc PR. I'll just go ahead and state that they're congruent. Arc PR and then arc LR. Those are both congruent because they're both equal to 90 degrees. Name three adjacent arcs that form a semicircle. So, semicircle, of course, is just half of a circle, or 180 degrees. So the only three right here we can use are going to be PR, RQ, and QL. PR, RQ, and QL. Remember, adjacent just means next to. That's how we got that. Okay, moving on to C3, which is on properties of chords. These first two problems will be just finding values. So in circle Z, if VZ is equal to ZW, okay, this tells me that these two chords, UT and ST, are equidistant from the center. So that means that they are congruent because of that statement. We know that SV is 21 and the measure of arc UT is 112. Okay, so there's a couple things I see here. Since I know UT and ST are congruent, also I see these little right angles here. So when a radius is perpendicular to a chord, that means it's bisecting it. So that means that this also has to be 21. And then we know that ST together would be 42. So we know that this is 21 and this is 21 because UT and ST are equal. Also the same thing with their arcs. We know the arcs are bisected when it's perpendicular and the arcs are congruent. So this is 112 and this would be 56 degrees, 56 degrees, 56 degrees, and 56 degrees. Alright, that's about all I really need to solve this problem now. So let's fill in the blanks. UT, which is the 21 plus 21 to give me the 42. WT, 21. ST, 42. Measure of arc XT, 56 degrees. Measure of arc ST, 112. And then measure of arc US. US is from all the way to here, so it's 112 times 2, so 200 and... Oh, wait. Yeah, US is not 136. Correct. Oh, actually, so look at this. They're trying to confuse you here. US is this arc, isn't it? Yes, it is. So US is going to be... UTS would give me the whole thing right here, right? Because and that's going to be a major arc. So US is going to be 360 minus 112 minus 112. You subtract it twice. And that is, of course, 136 degrees. And that's number 15. P16. GP and pH equal. Okay, I'll go again. Cool. GA 17. So that's 17. That's 17. That's 17. ED 37. AB is 87. Find everything else, okay? So I'm going to find EA and DB. They're the same, but we need to find them by using these two arcs right here, okay? So we're going to subtract 360 minus 37 minus 87. Okay, that's going to give us the sum of my two congruent arcs. So when you do that, you get this equal to, let's see, 360 minus 37 minus 87, 236 degrees. Okay. And remember, this is the sum of the two congruent arcs. So to get what they are by themselves, you do 236 divided by 2, which comes out to 118 degrees. So that means that AE is 118 and DB is 118. So their parts are 56 degrees each. Alright, and that should be enough for us to find what we want to find. DB, 17 plus 17, 34. EG is just 17. Measure of arc DB, 118. FA, 56 degrees. And the measure of arc DC is again also 56 degrees. And that's number 16. Moving on to number 17. P17. Okay. Find EF. So we have two congruent arcs. What this means is that these two congruent arcs, if I have two congruent arcs, then I also have two congruent chords, which are the same as the endpoints of the arc. So CD and EF are equal. So we can set their expressions equal to each other. Add 5x to both sides and add 1 to both sides. You get 14x is equal to 42. Okay, and then we divide both sides by 14 to get that x is equal to 3. So to find EF, we just plug in for what EF is. So 41 minus 5 times 3, so 41 minus 15 comes out to be 26. So EF is 26 units long. 18. Solve for x. We have an expression for the arc, measure of arc AB. Okay, and we have an we know arc BC is 106. What I'm going to do is try to find arc AC. We know they are congruent because those chords are equidistant from each other. So I'm going to do 360 minus 106. Okay, and that gives me 254. When that just tells me add the sum of arc AB and arc AC. So to get what they are each, since they're congruent, we divide 254 by 2 and get that together. I mean, each they are going to be 127 degrees. So now I solve for x by setting 10x minus 23 equal to 127. Add the 23 to both sides. You get that 10x is equal to 150. So x is equal to 15. And we're done. Number P19. The measure of arc DC is 12x plus 7. Measure of arc CB is 18x minus 23. Let's find DAB. We know these have to be equal to each other because they're equidistant from the center. So we'll solve for x, find either one of these, multiply that by 2, and then we will subtract from 360 to get DAB. That's our plan here. So DC So we'll set them equal to each other. 18x minus 23 equals 12x plus 7. So then we get 6x is equal to 30. So x is equal to 5. Now find either one of these. 12 times 5 is 60 plus 7. That's going to be 67 degrees. Okay, this will be also 67 degrees. So that times 2 is equal to 134. So then you do 360 minus 134, 226. So basically what we're going to do is the measure of arc DAB is 360 minus 67 minus 67, which comes out to 226 degrees. And that's the measure of arc DAB. Alright, P20. If DE is equal to GF, H, that means that we have two congruent chords. If chords are congruent, they are equidistant from the center, which means that HJ and JI are equal. So that helps us solve this by setting those two expressions equal to each other. 15x minus 64 is equal to 3x plus 20. Okay, we subtract 3x from both sides, add 64 to both sides to get the 12x is equal to 84. Dividing both sides by 12, x is equal to 7. So to find JI, that's equal to plug in 7 for x. So 15 times 7 minus 64. JI comes out to be 41, and that's our answer. Okay, next. Okay, sorry about that, my video cut out on me. We left off at P21, which talks about the two chords intersecting inside the circle. So let's look at our cheat sheet again and see what that tells us we can do with that. So we're dealing with segment lengths, so I'll go look at segment lengths and circles. Okay, I see chord / secants intersect inside the circle. Whenever this happens, all you got to do is take the two parts that are formed of the chord and multiply them together. They will be equal to the multiplication of the other two parts right here. So you see A times B, right? The A goes from there, the B right there, C, and it is equal to C times D. Okay, so that's how we'll solve this one. Number 21. All right, so where we're at, here we are. So we'll have let's see, 18 times our 2x minus 5. That's going to equal the multiplication of the other two parts. 14 times 2x plus 1. Okay, and doing that, now we simplify. So 36x, 18 times 5 is going to be 90, so minus 90 equals 28x plus 14. Okay, subtract 28x from both sides. You get, on the left side, we get 8x. Adding 90 to both sides, we get this is equal to 104. Divide both sides by 8. Well, x is equal to 13. Now we want to find TQ. TQ is just this 2x plus 1. So TQ is equal to 2 times 13 plus 1. 2 times 13 is 26 plus 1 is 27. Alright, number 22. In the diagram shown, explain with words a method for determining the values of x and y. Then find x and y to the nearest tenth. So this one was going to use the so to find y. Notice So notice that y is part of a chord formed by two chords intersecting inside the circle. So that means we can multiply the two parts like we did in the last problem in P21, and we can multiply 20 in the y equals to 16 times the 16, and that'll give us an equation for y. So we're going to multiply parts, the chord parts. So that leaves me with 20 times y is equal to 16 times 16. Alright, so let's simplify and solve for y. So 20y is equal to, so 16 times 16 is 256. Divide both sides by 20, we get that y is, it's going to be a decimal, it'll be 12.8. Okay, now that works. Now we're going to solve for x. So x is a hypotenuse of a right triangle with legs of length 16 and 12.8. So we solve for x by doing Pythagorean theorem, right? So x squared is equal to 16 squared plus 12.8 squared. So x is equal to the square root of whatever that is. And that's approximately, let's see, I'm going to solve the only thing on my notes. Square root of 16 squared plus 12.8 squared is 20.49. That is x. And we're done. Alright, that's all for C3. Now we'll move on to inscribed angles from lesson C4. First things first, so remember that the measure of an inscribed angle is equal to half the measure of the intercepted arc. So this is different than when we had central angles. Central angles were equal to the measure of the intercepted arc, but inscribed angles, because they're different, they're not on the, their vertex is not at the center, the vertex is just on the circle. This makes, so we have this new relationship to where it's half the measure of the intercepted arc. Okay, so let's look at number 23. Find the measure first. We'll find the measure of arc ML, okay, which is right here. Let's see. It is the intercepted arc of this angle MJL, right? Or, yeah. So, I know this 59 degrees is half of whatever the measure of ML is. So, 59 times 2 is going to give me whatever this is, and that comes out to be 118. So ML is 118. Now next, we're going to find the measure of angle JLK. Alright, so that's this angle right here. It will be half of this intercepted arc, which in this case is this 134 degree angle. So 134 divided by 2 is equal to 67 degrees. Okay, next, JLM. That is this angle right here. So to do this one, first thing I want to notice right here is JML, of course, okay? It's a right angle, and let me tell you why. It is a right angle because it intercepts a diameter. Anytime you intercept a diameter, it is a 90-degree angle. It's a right angle. So to find my angle right here, to find an angle I'm looking for, which is JLM, I'll do 90 minus 59, because I know those two other angles have to add up to 90. Okay, so that's equal to what? 31 degrees. Yep. And the measure of arc MJ is going to be double this angle right here, because MJ is the intercepted arc of JLM. So we'll just 2 times 31, that's equal to 62 degrees. And that's that one. Number 24, solve for x. So we're given an expression for this angle STU. It's a inscribed angle, so it will be half of its intercepted arc, and that arc is 94 degrees. So what I want to do is set up my equation as just like this. 9x minus 25, that's going to be equal to half of 94, so 94 over 2. 94 over 2 is equal to 47. Okay, so now we solve for x easily. 9x is equal to 72, so x is equal to 8. Next, if the measure of angle BCD is 7x plus 10, and the measure of angle BAD, the measure of arc BAD is 19x minus 50, find the measure of arc BAD, the number. So arc BAD is double whatever the inscribed angle is, okay? So I'm going to multiply my inscribed angle times 2 to get the expression for my arc. And that's how I'll solve. So 2 times 7x plus 10 equals 19x minus 50. 14x plus 20 is 19x minus 50. Subtract 14x from both sides. 5x on the right side. Add 50 to get a 5x is equal to 70. Dividing both sides by 4, x is equal to 14. However, that's not what I'm trying to find here. I'm trying to find BAD. So plug in to our formula for BAD. So we plug in 14 for x in this. So 19 times 14 is 266 minus 50. So the measure of angle BAD is 216 degrees. Number 26. The measure of angle PQS, okay, this angle right here, is 6x plus 1. And the PRS is 34 minus 5x. So they both have the intercepted arc PS, okay, which is what we're trying to find. Since they both intercept the same arc, we know that those angles are congruent. So we can set these two expressions equal to each other and solve for x first. So adding 5x to both sides and subtracting 1 from both sides, you get that 11x is equal to 33. So x is equal to 3. Now, to find the measure of arc PS, we're going to first find one of these measures, okay? So let's just look at that. Look at this one, 6 times 3 plus 1. That's 18 plus 1, so it's 19 degrees. So the measure of arc PS, the measure of arc PS is going to be double this angle measure, okay? So measure of arc PS is equal to 2 times 19, and that's going to be equal to 38 degrees. Number 27. The measure of angle K is equal to, excuse me, 1 second. Yeah, the measure of angle K is equal to 8x minus 19, and the measure of angle M is equal to 5x plus 43. Find the measure of arc LN. Okay, so let's find that. To do this, what we're going to do is we're going to so what we have to remember, we have this quadrilateral here. It is an inscribed quadrilateral is what we call it. And if we look at our cheat sheet, it tells us some stuff about inscribed quadrilaterals. Okay, so let's see what it says about those. In inscribed quadrilaterals, the opposite angles are supplementary. Okay, and what that means is that they add up to 180. So I'm about to go, just give me 1 second right here, and we will go look at the cheat sheet, okay? So we're looking at our cheat sheet. Down below, over here, keep on scrolling. I'm looking at angle measures. So inscribed quadrilateral, that tells me the opposite angles add up to 180. So that's what I'm going to do. Okay, so let's solve this one. Go back to our problem. And what we're going to do is set this one up. We'll have, I'm just going to write right here, angle K and angle M are supplementary. Because they are opposite angles of the inscribed quadrilateral. Alright, so here we go. We'll do 8x minus 19 plus 5x plus 43 equals 180. 8x plus 5x, that'll give me 13x. Then 43 minus that 19, and that's going to be 24 plus 24 equals 180. Subtract 24 from both sides. 13x is equal to 156. Dividing both sides by 13, x will then leave me with x equal to 12. Okay, now to find the measure of arc LN, okay, so that's this arc right here. Boom. So notice, remember, angle M is just an inscribed angle in this circle. So whatever this measure angle is, it's going to double that, will give me the arc that I'm looking for, which is LN. It should probably be LKN actually, though. Oh, excuse me. LN is the minor arc. I'm making a mistake here. This is LN. Boom. So that's an easy mistake to make. But you notice it's smaller than a half circle, so it has to be that. So instead of looking at angle M, we will look at angle K. Alright? Find angle K, double it, you'll get your LN. Alright? So, to find angle K, we'll plug in our 12 in for x here. So 8 times 12 minus 19. That gives me 77 degrees. Right? So the measure of arc LN is equal to double this. So it's going to be 154 degrees. Alright. 28. Find the measure of arc WX. Okay, that's this arc right here. Okay, we know two angles, 6x minus 7 for WVX and WYX. Know those two angles to be given expressions for them. They are, of course, congruent because they both intersect arc WX. So we'll find X first before we can find the arc we want. So set them equal to each other. 10x minus 47 equals 6x minus 7. Subtract 6x from both sides. 4x is equal to whatever 47 minus 7 is. That's 40. So x is equal to 10. Okay, now find either one of the angles. Since they're equal, we can plug into either one. And then that'll give us half of WX. So first let's just do this. So 10 times 10 minus 47. That's 100 minus 47, which is what, 53 degrees. Okay, now to get the measure of arc WX, that's just double 2 times 53. That'll give me 106 degrees. 106. Alright, finally we have this huge problem right here. Okay, so we're going to find 21 different angles here, and we're going to have fun with it too. This will be a mixture of central angles and inscribed angles. So let's see what we're given. We're given that G is the center of the circle, AD is the diameter, arc AB is 78 degrees, okay. Arc FE is equal to 105, and then arc CD is equal to 42, and I forgot to add one on here, and I want you to add it for me real quick, please. We also know that the measure of arc ED is equal to 27 degrees. So right here, 27. Okay, so add that to your paper. Okay, now before I even look at that thing, I like to just kind of remember. I like to fill in what I can figure out. All right, so I can find AF now, can't I? By doing, since this is AD is the diameter, these three arcs will add up to 180. So we'll do 180 minus 105 minus 27. That's 48 degrees. Okay, cool beans. Now I can also find BC by doing 180 minus 78 minus 42. That's 60 degrees. Our BC is 60 degrees. Now I should be able to solve every angle I need to. Okay, so let's start with angle 1. Angle 1 is this angle right here. It is an inscribed angle because it has the vertex on the circle, and then it intercepts the arc BC, which is 60 degrees. So we'll take half of that to get the measure of angle 1, which is 30 degrees. Okay. Awesome. So I'll go ahead and write this right here too. Then measure of angle 2. Measure of angle 2, you see angle 2 is an inscribed angle that intercepts this diameter AD. That automatically tells me that it is a 90-degree angle. Angle 3. Angle 3, another inscribed angle that is intercepting this arc CD, so it's half of 42, so it's 21. And then angle 4, let's see what that is. Another inscribed angle which is intercepting arc AB, so we take half of 78, so it is equal to 39 degrees, I think. Yes, yeah. Angle 5. All right, angle 5 right here, it's going to intercept AB as well. So it is going to be the same as angle 4, right, which is 39. So they're both 39 degrees. Angle 6 now. Okay, angle 6 is right here. It's an inscribed angle intercepting AF, which is 48 degrees, so we take half of it to find the measure of angle 6 is 24 degrees. Okay, angle 7 now. All right, angle 7, let's find it on our thing here. Angle 7, right here. I'm going to leave that one for a second. Okay, we'll leave that one for a little bit. Now, angle 8. So what I noticed that I need either angle 7 or angle 8. First thing I do notice that 8 and 7 together are a right angle because that whole angle together intercepts AD. Okay, cool. Now, let's see if we can get 9. If I can get 9, it might make 8 a little bit easier. Okay, or for now, I'm not going to worry about the list right now, too. I'm just going to fill in what I know based on what we have so far, okay? Because we have a lot of stuff we can figure out without having to go down the list. All right, angle 9. I'm looking at that one. Angle 9 is an inscribed angle that intercepts arc FD, which is 105 plus 27. So 132 altogether. We divide that by 2. We get that the measure of arc angle 9 is 66 degrees. Okay. Angle 15. Angle 15 is a central angle because its vertex is at the center, so it's equal to its arc of which is 48 degrees. So measure angle 15 is 48 degrees. Now I can find angle 8 by adding these two up and subtracting from 180. So 180, because these are 3 angles in a triangle. 180 minus 48 minus 66 is also 66. So that's that. Now I can find angle 7. Since together they form a right angle, we will do 90 minus 66 to get that angle 7 is 24 degrees. All right. Dealing with central angles again, angle 16 is another central angle for the arc FE, so it is also 105. Similarly for 17, it's an essential angle for DE, so that's 27 degrees. Okay, let's find angle 21. So it's the third angle in this triangle, so we'll do 180 minus 105 minus 24 to get that it's equal to 51 degrees. All right. So I noticed that 18 and 21 form a linear pair. So 180 minus 51 will give me angle 18, which is 129. And that means angle 20 is also 129 because they're vertical angles with angle 18. And then 21 and 19 are also vertical angles, so 19 has to be 51 degrees. Okay, let's find the ones up here now. Angle 11 is a triangle with the angles 1 and 2, so I can do 90 minus the 30 since this is a 90 degree angle. That'll give me 60 degree right here, so 13 is also 60 degrees. 12 and 14 will be 180 minus the 60 because 12 and 13 are linear pair, then 12 and 14 are vertical. Okay, that gives me 120 degrees for both of those. And I think we have found everything we need to. So let's fill in we need angle 10. Okay, angle 10 is just an inscribed angle for this 42 degree arc. So it'll be 21 degrees. And with that, we can fill in the rest of the blanks now by just looking at our. So to get angle, like I said, let's fill in our stuff we know. Okay, so measure of angle 7 we found to be 24 degrees. 8 we found to be 66 degrees. 9 was also 66 degrees. Then 10 was 21 degrees. 11 was 60 degrees. 12 was 120. 13 was 60. 14 was 120. 15 was 48. 16 was 105. 17 was 27. 18 was 129. 19, 51. 20 was 129. And then 21 was 51 degrees. And that is all we have about inscribed angles. We move on to the longest section we have is less than C-5. We have a lot of problems from this one. Tangents and secants. Martyr claims that it's possible to draw one line tangent to a circle at 2 points. Is her claim reasonable? No, it's not reasonable. By definition, a tangent intersects a given circle exactly once. It can't intercept a circle twice because if you look at the, right, if I have this tangent line, it's here, it's at this circle, that's where it gets the closest. It gets there, it intersects once, and then it goes on and on forever in the other direction. Since the tangent is a straight line, it cannot intersect the circle another time. Okay, so that's my answer. Good for me. Number 31. In the diagram, CA is tangent to circle P. Stop there. If I have if it's tangent to a circle P, this radius that is drawn to the point of tangent C is perpendicular to the tangent line. So there's a right angle right there. The radius of circle P is 8, so that's 8 centimeters right here, and that's also 8. PB is. We know that BC is 9 centimeters. We want to find AC. Okay. 9 plus 8 together gives me 17, right? So, I know that X is going to be, doing the Pythagorean theorem, that's what, X squared plus 8 squared equals 17 squared. Remember, we've done Pythagorean theorem so much we can write it as a shortcut now. X is equal to the square root of the hypotenuse squared minus the other leg squared, so 17 squared. Minus 8 squared, and that comes out to be 15, so AC is equal to 15. Alright, next for 32 through 35 we'll use this picture right here. If the measure of angle MPQ, right, is 48 degrees, find that measure of arc QM. So we're finding this arc right here. Alright, so notice that this angle right here, with this angle we have two tangent lines. That are tangent to the circle, okay? So, let's see if we have anything about angle measures dealing with two tangent lines. So we go down to arc and angle measures. Two tangents intersect outside the circle. So two tangents right here. Cool. Alright. So to find the measure of our angle on the outside, it's just 180 minus this arc right here. Okay? It's supplementary to this arc. Okay. This shouldn't be 360 minus measure of arc PDC. Gosh, this should be measure of arc BDC minus 180. That's what it should be. Excuse me. So, anyway, go back to our problem. All I need to do is, since I know that this 48-degree angle is supplementary with arc QM, we can find the measure of arc QM by just doing 180 minus 48. Okay, and we get that it's equal to 132 degrees. Alright, so I will be using this picture again. The numbers will change, so we're going to go ahead and look at the next problem. So this next one says, if MNQ, arc MNQ is 200 degrees, then what is MPQ? So MNQ is 200 degrees. We want to find MPQ. Okay, MNQ, which is this whole arc right here, that's going to be 200. Alright. If that's 200, if we want to find MPQ, so to do this, alright, now back to our cheat sheet. I had the whole thing with, if I'm given the major arc right here, the formula that I kind of changed, you just take the measure of the major arc, subtract 180, and that'll give you the measure of your angle outside there, okay? Which is what we're trying to find in this case. So all we need to do is, so the measure of angle, MPQ, is equal to 200 minus 180. So the measure of angle MPQ, if that is going to be equal to 20 degrees. Okay, number 34. If QN is equal to 125 and QR is 83, find the measure angle 1. So QN is 125. QN, 125. And then QR is 83. Find the measure angle 1. So with this setup right here, I have a tangent and a secant, trying to find the angle intersecting when they intersect outside the circle. So look at our cheat sheet for intersecting outside the circle with a tangent and a secant. Oh, right here, voila. All we got to do is take half of the bigger arc minus the smaller arc. Okay, that's what we'll do. We're given the bigger arc and the smaller arc. The bigger one is the 125. The smaller one is the 83. So the measure of angle 1 will be equal to 125 minus 83. Divided by 2. Alright, so in my calculator, 125 minus 83 divided by 2 is so it's basically 42 divided by 2, which is equal to 21 degrees. Okay, and then in number 35, we have different numbers again. So we're given that the measure of arc in QR, so this whole thing right here is 260, and the measure angle 1 is 45 degrees. Find the measure of arc QN. Okay, so this one, I'm gonna be honest with you, is a little bit difficult. To make this to be even useful with this, I need I'm gonna have to use a system of equation with this. Let's talk about what that is. So I know a formula for the angle 1 in terms of the two intercepted arcs, right? I don't know those though. We'll call them X and Y. Okay, so together we know that NQR is 260, so QN plus QR, or X and Y, will add up to 260, right? So I'll say that X plus Y is equal to 260. Okay, I also know I can set up using our things about a tangent and a secant, basically meaning that 45 is equal to X minus Y. X is my bigger one, right? Yes. Okay, and that's divided by 2. So 1/2 of the difference of the two intercepted arcs. So multiply both sides by 2, I'll get that x minus y is equal to 90. So I have two equations, systems of equations, two equations, two unknowns. We're going to solve these using what we call, remember, elimination method, meaning I just add up the two equations. Whenever I do that, let's just add them and see what we get. X plus x is 2x. Y plus negative y, those cancel out to give me 0. So all I'm left with is 2x is equal to 350. Okay, now I can solve for x. Divide both sides by 2, and x is equal to 175. Alright, so x represented Qn, that's what we want to find. So the measure of arc Qn is equal to, 175 degrees. Alright, 36. Is segment AB tangent to circle C? Okay, we have this right here. We want to see if it's tangent. If it's tangent, that means that this would be a right angle, right? So what we're going to do is we're going to see if this is in fact a right triangle. To do that, you plug in your side lengths into Pythagorean theorem to see if it satisfies, okay? So this 4.8 AC right here is a radius, so this is also 4.8. So my legs are 4.8 times 2, which is 9.6, and then 7.2. So what I'm going to do, I'm going to basically solve for the hypotenuse, as if I didn't know it, okay? And if I end up getting 12, then that shows me that this is a right triangle, okay? So we'll do the square root of 9.6 squared plus 7.2 squared. Okay, so this is the Pythagorean theorem. I'm trying to just skip in some steps with it. Plugging that in my calculator. So square root of 9.6 squared plus 7.2 squared. I press equal and I get that's equal to 12. Okay? So that's equal to my hypotenuse. Alright? So what this tells me is that triangle ABS is a right triangle. And thus, yes, AB is tangent to circle C. Because of that reason right there. Alright, P37. Is AB tangent to circle C? We'll plug in our 15 and our 11.2 into the Pythagorean theorem and see if they equal 6.8. So do the square root of... Oh, okay. No. Careful. This little part outside the circle is 6.8, so this is 11.2. We'll see if they equal... Let's see if they equal 18, right? Boom, boom, boom. So, square root of 15 squared plus 11.2 squared in my calculator gives me around approximately 18.72, which is not equal to 18, so big no, and we're done. 38. Solve for x here, okay? Our radius is 8, so this is also 8. So 8 plus 11 is 19. Alright, so to solve this, x is going to be equal to, it's a leg, so it's going to be the hypotenuse squared. Square root of the hypotenuse squared minus the leg squared. 19 squared minus 8 squared square rooting that, it gives me in my calculator, it gives me 3 square roots of 33. Okay, and that's approximately, if you want to give you both answers, 17.23. And we all know this is a right angle. That's because of the fact that that's a radius intersecting a tangent line, which are always perpendicular. Okay, 39. Solve for x again here. Okay, so this leg right here will be 6. So x is going to be square root of 3.2 squared plus 6 squared, which is equal to 6.8. That's my answer. 40. If DE and EF are tangent to circle G, find EF. Okay, since there's tangent to circle G, both coming from the same point, those two tangents have to be congruent. So we can set the two expressions equal to each other and solve for x. 10x minus 19 equals 4x plus 23. Okay, so subtract 4x from both sides, add 19 to both sides, you get 6x is equal to 42. Alright, divide both sides by x, 6, you get x is equal to 7. Now to find EF, we plug in 7 for x. So 7 times 10 times 7 minus 19. 70 minus 19 gives me approximately 51 degrees, or 51, just 51. No degrees here. All right, number 41. Find the perimeter of triangle PQR. Okay, so this is a circumscribed shape, right? Meaning that every side is tangent to the circle inside of it, which is very useful. Remember, we know that tangents coming from the same point are equal. So since this is 5.9, 5.9, okay, that means this is 12.2. And then to find these two parts right here, I know the whole thing right here is 27.4. So 27.4 minus this 5.9, that's equal to 21.5. So this is 21.5. And then my perimeter now will be equal to, let's see, 2 times 21.5 plus 2 times 5.9 plus 2 times 12.2. I have 2 of everything because look, I have got 2 of every length right here. In my calculator, plugging that in, that gives me that my perimeter is equal to 79.2. Alright, 42. Find the measuring angle AED and the measuring angle DEC. Okay, so I've got 2 chords intersecting inside the circle, and we're trying to find those angles in there. So let's look at our cheat sheet. For angle arcs and angle measures, we look at see where they intersect inside. Chord / secant intersect inside the circle. Alright, so if I look at what the measuring angle 1 is, it'll be half of the sum of its 2 intercepted arcs. So AB and CD right here, you add those 2 arc measures up, divide by 2, you get your angle in the middle now for angle 1. So we'll use that to do this. So AED, we are going to, so my plan here is to first use that formula we just talked about to find AED, okay? And then whatever I get, I'll subtract from 180 to get DEC because they form a straight line. So the measure of angle AED is just equal to, add those 2 intercepted arcs up, so 92 and 140. And those divided by 2 when you add them up, okay? So 92 plus 140 divided by 2 in my calculator gives me 116 degrees. Now, the measure of angle, like I said, the measure of angle DEC is equal to 180 minus that, because they're a linear pair. 180 minus 116 is 64 degrees. Number 43. Find the measure of angle QST. That's this angle right here, okay? So remember, whenever I have, looking back at my cheat sheet again, we have a tangent and a secant intersecting on the circle. Looks just kind of similar to this one. So to get the angle measure, it's half of its intercepted arc, okay? So let's look at, see what we have. QST is half of arc QUS, right? So let's find that by, we're given arc QS to be 98 degrees. So we'll do 360 minus this 98, and that's equal to 262. So this arc right here, 262. So the measure of angle QST is equal to 262 divided by 2, which is going to give me 131 degrees. So that is the angle I was looking for. Not the only way we could have done this. You could have found QSR and then subtracted from 180 to get QST, because they, of course, they're a linear pair right there. All right, measure of angle KLM. KLM is this angle right here. So here I've got two secants intersecting outside the circle. Let's see what we know about from our cheat sheet about those type of angles. So we're looking at angles and arc measures, two secants intersecting outside the circle. Boom, bottom left right here. All you do is, to get that angle, you take your intercepted arcs. In this case, it's DE and BC. You subtract the bigger one minus the smaller one, and then divide by 2 to get your angle measure. And that's what we will do here. I'm very lucky and fortunate to be being given these two angles. So all I'll do is the measure of angle KLM. That's going to be the 125 minus the 51 divided by 2. Which is the same as 1/2 times that. So 125 minus 51 divided by 2 in my calculator gives me this to be 37 degrees. All right, number 45. Find the measure of angle XYZ. Okay, this is a secant and a tangent intersecting outside the circle. So if you look to find the angle measure that we're trying to find, XYZ, that outside angle measure, it's still also the half of the difference of the intercepted arcs. Okay. However, I'm given this arc XW, and I'm given arc XZ. I need WZ to be able to do this. So that's going to be equal to 360 minus the other two arcs. Doing that, it's going to be equal to 156. The arc is. So now to find the measure of angle XYZ, that's going to be equal to 156 minus 68. All of that divided by 2. And when we do this, it's equal to 44 degrees. All right, number 46. This time I have two tangents intersecting outside the circle. All right, I know that this angle we're trying to find, FGH, is supplementary to arc FH. So the measure of angle FGH is just 180 minus 101, which is 79 degrees. Number 47. Okay, find the measure of arc RU. Remember, when we have two chords intersecting inside the circle, the angle in the middle is going to be equal to half of the sum. So now we're trying to find the arc, though. So I need this angle. Notice that this angle right here that I just drew an arrow to, is a linear pair with this 88 degree angle. So we do 180 minus 88, and that gives me that angle inside is going to be 92 degrees. All right, so now I know that that angle will be equal to half of the sum of its two intercepted arcs. So if we call this x plus 35 over 2 That's the same as 1/2 of the sum of those two, right? So we'll multiply both sides by 2 first. I get that that's equal to 184. 92 times 2 is 184. So you go to x plus 35. So subtracting 35 from both sides, you get x is equal to 149, which means that the measure of arc RU is equal to 149 degrees. All right, number 48. So this looks like it would be two tangents almost, but do you notice this little bitty space right here? This is a tangent and a secant. Okay, so that means we just take, we're going to find MLP, which is this right here. We don't know, we'll call it X. We know that this angle, the 75-degree angle, is half the difference between the bigger minus the smaller intercepted arcs. So we'll set up our little equation thing. 75 is equal to x minus 91. That's times 1/2, so it's over 2. Multiply both sides by 2. 75 to get rid of the fraction. 75 times 2 is 150. That's equal to x minus 91. Adding 91 to both sides, x is equal to 241. So that means that the measure of arc MLP is equal to 241 degrees. All right, 49. Very similar thing right here, except this time we're looking for the DF, okay? We still have a secant and a tangent intersecting. No, two secants, excuse me. All right, but it's the same process for doing this. We know our angle, which is 52 degrees. That's equal to the difference of the two arcs. So it's minus x this time because x is the smaller arc this time. And of course, divided by 2. Multiply both sides by 2. 104 is equal to 162 minus x. Add x to both sides because we want x to be positive. And then subtract 104, you get that x is equal to 58 degrees. And so that means that the measure of arc DF is equal to 58 degrees. 50. Given that the measure of angle IFG, so this whole angle right here is 128. Find the measure of angle IHF, arc IHF. So we know, of course, that this, since it's a tangent and a secant intersecting on the circle, I know that the arc measure is, or the angle measure right here, is half the measure of its intercepted arc. So going backwards, we'll double the angle to get the arc. So the measure of angle arc IHF is equal to 2 times the measure of that angle, that 128. So it's equal to, where's my thing? 256 degrees. Okay, that's 51. So if the measure of arc DH is equal to 11x plus 7, GF is 5x plus 9, and then GEF is 10x minus 22. So right here, we want to find DH, okay? Right here, I've got technically, so it's two secants intersecting inside the circle, right? The angle measure is going to be equal to half of the sum of the two arcs. So 10x minus 22 equals those two arcs, which are 11x plus 7 plus 5x plus 9, all of that over 2. I'm going to multiply both sides by 2 right now, okay? Actually, no, I'm not. We can do this. Let's try it first. Let's simplify the top right here. 11 plus 5 is 16x. 7 plus 9 is 16 plus 16 all over 2. Both those numbers are even numbers, so we can divide by 2 very easily without having to do anything. 10x minus 22 so 6 is equal to, then we do 16 divided by 2 is 8. All right, that's what I got here. Subtract 8x from both sides, you get 2x on the left, add 22, 2x is equal to 30, so x is equal to 15. So the measure of DH is going to be, you just plug in 15 for x. And in doing that, you get the x is equal to 15, of course, right? And then we plug in that. Measure of DH is 172, excuse me. All right, number 52. The measure of arc MOP, so this arc right here, which is 11x minus 38. And then LMP, angle LMP, is 3x plus 41. Find NMP, the other one, okay? So, first thing, let's find x, okay? I know that 2 times that angle is equal to the intercepted arc. So 6x plus 82 is 11x minus 38. Subtract 6x from both sides. Add 38 to both sides. 82 plus 38 gives me 120. Dividing both sides by 5. 120 divided by 5 is equal to 24. So, my goal here is to find LMP, and then once I do that, I subtract from 180 to get NMP. So 3 times 24 plus 41, that gives me 113 degrees. So, the measure of angle NMP is 180 minus 113, which is 67 degrees. All right, 53. The measure of arc RU is 16x minus 13. And then SU is 11x minus 24. And then STU, the angle, is 3x plus 1. Find the measure of SU. So, a secant and a tangent intersecting, of course, still are just half the difference of the intercepted arcs. So, the angle, 3x plus 1, equals the bigger arc, which is the 16x minus 13, minus the smaller one. So, remember when you do something minus a whole expression like that, the negative distributes, so it's negative 11x plus 24. That's all over 2. Okay, I can tell this isn't going to give me even numbers with my coefficient, so I'm going to multiply both sides by 2. Doing that, I get 6x plus 2 is equal to, then we simplify this to 5x, simplify the top at least, so 24 minus 13 is equal to 11. So subtract 5x, you get just x on the left. Subtract 2, you get x equal to 9. We're trying to find SU, however, though, so the measure of SU, just plug in. So it's 11 times 9 minus 24. So 99 minus 24 gives us a total of 75 degrees. All right, 54. Almost done, guys. So this one we have dealing with segment lengths for 2 secants intersecting. Look at our cheat sheet. For segment lengths, which is this little part right here, if 2 secants intersect outside the circle, you have this relationship right here. basically it says the outside part times the whole secant, which is the a times a plus b, equals the other outside part times the other whole secant. That's how we'll set up our equation here. So the outside part for this bottom secant is 7. We multiply that by the whole thing, which would be recognized by x plus 7. That's going to be equal to the outside part of the other one, 6 times 6 plus 15, which is 21. All right, so distribute this. 7x plus 49 is equal to 6 times 21, which is 126. Subtract 49 from both sides. 7x is equal to 77. X is equal to 11. And we're done. This one, secant in a tangent. Okay, if you look back at your cheat sheet, I'm not going to draw down there. It tells me that this square, this part of the tangent square is equal to the same thing we did for secants up there. So 12 times x plus 12. So 12 times x plus 12 is equal to 18 squared. So 12x plus 144 is equal to 324. Subtracting 144 from both sides, you get that 12x is equal to 180. So x is equal to 15. 56, find CD here, two secants intersecting outside the circle. Okay, very similar to what we did earlier. You take the outside part times the whole thing, right? So 2x minus 7 plus 9 will give me 2x plus 2. That's going to equal 7 times 11 plus 7 is 18. So I've noticed this, right? If I just divided both sides by 9, I'd get rid of this, right? And 18, I saw this. The only thing I noticed is that 18 is a factor of, or 9 is a factor of 18. So if I divide both sides by 9, I get that 2x plus 2 is equal to, so 18 divided by 2, 9 is 2, times 7 is 14. Oh, I made it much simpler now. Subtracting 2, 2x is equal to 12, so x is equal to 6. Alright, now I'm not done yet. I need to find CD, but CD is just 2x minus 7, so 2 times 6, which is 12 minus 7. CD is equal to 5. And with that, we have finished all the multiple problems for C-5 in our review. Now we move on to our last section, which is C-6, which is the equation of a circle. Okay? I want you to correct this on your thing. Make this a 6, please. And then also we want you to make this, on this one over here, make this a 9. Alright, cool. So, first, remember our equation of our circle is of the form, in standard form, is x minus h squared plus y minus k squared equals r squared. Okay, center from this equation is just the h comma the k. That's our coordinate for it, and then r equals radius. Awesome. So looking at our standard form equation, my center has to be -2, +6. Remember, if this is a plus, the coordinate will be a negative. If it's a minus, the coordinate will be a positive. Okay. Then our radius is just the square root of this number right here, 16, so it'll be 4. All right, so the first thing to do, plot your center. So -1, -2, let's see, we go up 6, 3, 4, 5, 6. All right, now I need to find 4 points on the graph, all in the circle, and I do that by counting the radius away from the point. So I go up 4 here. This gives me a point on my circle. I go to the right 4, of course, gives me a point on my circle. Go down 4, point on my circle, and then to the left 4, it gives me a point on my circle. And I'm going to be real fancy here, and I'm going to use my little fancy thing that can draw perfect circles. Okay, so let's see if I can get it. Might have to fix it a little bit. That's okay. So here, go up a little bit, go up a little bit. That looks pretty darn good right there. That's my circle. Awesome. That's how you draw a circle, guys. It's really not too bad. All right, now 58. Identify the center and diameter given diameter this time. Ooh, different. Okay. So, given the following equation. Then graph the circle. So, since this is just x squared, that automatically tells you my x coordinate is 0. And then that's a plus 6, my y coordinate is negative 6. Okay. So, first find the radius. If the r squared is 9, r will be equal to 3. So that means my diameter is 6. Awesome. So first, graph your center. So 0, negative 6. Alright, now we go do those 4 points with the radius. Go up 3 right here, right 3, down 3, and left 3. Here's my circle. Alright, let me adjust it just a little bit. And voila, you have your circle with your 4 points in there. Basically, your circles do not have to be perfect. I just want to see mainly want to see the center and the 4 points. Okay. All right, write the equation of the circle in standard form below. So if I am going to, what I'm going to do is I'm going to draw my 2 diameters, the vertical and the horizontal diameter, and wherever they intersect is going to give me my circle. My center, excuse me. So those are my 2 diameters right there. Where they intersect would be coordinate 0, negative 2, right? Okay. Now let's find the radius. All I'm going to do is count up until I hit the circle from the center. 1, 2, 3, 4, 5, 6, 7, 8. So that means my radius is equal to 8. So that tells me that r squared is equal to 64. And now I have my center, my r squared. I can write my equation of my circle. Since the x coordinate is 0, this will just be x squared. And that's a negative number, so this will be y plus 2 squared equals the r squared, which is 64. Actually, I like doing this thing. And that's my answer. Now we're going to be writing for 60 through 69. We'll write the equation of a circle in standard form with the given characteristics. So number 60, super easy. You're just given the center and the radius. Okay. I'll go ahead and write what my r squared is. Since the radius is 7, r squared will be 49, and thus my center of my circle will be x plus 3 squared plus y minus 4 squared equals 49. 61. So this time I'm given the diameter. I can easily find the radius by taking half of that. So my diameter is going to be, so my r squared is 100. And then I'll have my center, I have my r squared. That's all I need to write to draw the circle. Okay, so this will be, my circle equation will be x plus 9 squared plus y squared equals 100. 62. Again, given the center diameter, so take the radius is just 9 divided by 2, which is 4.5. So r squared is equal to 4.5 squared, which gives me 20.25. So you have my center, have my r squared, can write my equation. X plus 7 squared plus y plus 1 squared equals 20.25. Number 63, we're given the radius and center, square the radius. Remember that when you have a square root that is squared, it's just whatever's on the inside of the square root. Okay, so I'm good now. R squared is 89, so my equation is x minus 12 squared plus y minus 5 squared is equal to 89. 64. This time we're given the circumference. Okay, if you're given anything, always good rule of thumb. If you're not given the radius, find the radius because you need the center and the radius to solve your equations. Okay, so if we're given the circumference to be 12 pi, I know that 2 pi r is equal to 12 pi. Divide both sides by 2 pi. So r is equal to 6. And thus r squared is equal to 36. We have our center to be 2, negative 2. So our equation is x minus 2 squared plus y plus 2 squared equals 36. Number 65. This time we're given the area. So remember, when we're given an area, it's pi r squared. That equals the 225 pi. Divide both sides by pi. R squared is equal to 225. Alright, I'm going to leave it like that. I don't need to take the square root. I don't need to find r because what I'm looking for is r squared. Right? Because that's my equation. My circle has equals r squared. So, now r squared is 225. Center is 0, 10. That's all we need. X squared plus y minus 10 squared equals 225. Number 66. So these are the harder ones. Okay, our last 4 problems here. We're given the center and the point on the circle. If we remember, the distance between the center of a circle and any point on the circle is equal to the length of the radius. So the radius is the distance. So since we have coordinates, we will do the distance formula. So my r is going to be equal to the square root of, you subtract your x's, so 9 minus negative 4, it's 9 plus 4 squared. That's plus, subtract the y, so negative 1 minus 7 squared. Oh, excuse me. I messed that all up. Negative 1 plus 4. See, it's very easy to make a mistake when you're doing this stuff, guys. Just be careful. Negative 1 plus 4, that give me 3 squared, plus 9 minus 7 is 2 squared. So 9 plus 4, square root of 13. Stop there, okay? We're going to automatically square this because remember we need r squared. So r squared will be 13 because you square the square root, gets rid of it. So my equation will now be x plus 4 squared plus y minus 7 squared equals 13. 67. Endpoints of a diameter. Okay, so if we have a circle and then we have a diameter drawn through the circle, remember we know it goes through the center. Alright, to get the center, we can just take the midpoint of this diameter because the midpoint of a diameter is always the center. So, center will be, remember the midpoint formula is add the x's, divide by 2 to get the new x coordinate, add the y's, divide by 2 to get the new y coordinate. So, negative 18 plus 8 over 2, comma, negative 3 plus 11 over 2. Negative 18 plus 8 will be negative 10 over 2 is going to be negative 5. 11 plus negative 3, that gives me 8 over 2 is 4. So that's my center. I'll take the center, I'll pick one of these points because I know they're both on the circle, and we'll find the distance between that, and that'll give us our radius. So, r is equal to negative 5 minus negative 18, so it's plus 18. Square it plus, do the same for the y's. 4 minus a negative 3, so it's 4 plus 3. So that's equal to the square root of, this is 13 squared plus 7 squared. That's 250, that's 169 plus 49. And that gives me 218. So r squared. So my center, with my center negative 5, 4, and my r squared 218, my equation is x plus 5 squared plus y minus 4 squared equals 218. Alright, let's do 2 more problems and then we'll be done with our review. So again, we have one just like number 66, which is given the center and the point on the circle. All we need to do is find the radius using the distance formula. So 13 minus 1 squared plus negative 5 minus 0 squared. 12 squared plus negative 5 squared. That equals the square root of 169, which of course is 13. Okay. However, we don't need to take the square root because we're squaring it. So r squared is equal to 169. With our center to be 1, 0, we have our equation to be x minus 1 squared plus y squared equals 169. And then our last problem of the review, number P69. We're given the endpoints of the diameter to be negative 19, 0, and 19, 0. Okay, so find the center, do the midpoint. Negative 19 plus 19 over 2. 0 plus 0 over 2. This cancels out to give me 0, so my center is just 0, 0. Now, pick one of the points, plug into the distance formula. So we'll get r is equal to the square root of 19 minus 0 squared plus 0 minus 0 squared. That's just the square root of 19 squared. 19 squared is 361. So r squared is 361. So my equation, since the center is 0, 0, we'll just have x squared and then y squared. Very simple, nice equation. I like it. And with that, we are done with the entire Activity C review, all 69 questions. If you have any questions on any of my solutions, or if you think I got something wrong, go ahead and send me an email, let me know. But thanks for watching, and I hope you do well on your test. Thanks.